Welcome back to the deep dive. Today we're kind of shifting gears a bit,
Mm-hmm.
moving from those big sustainability concepts into, well, the real nitty-gritty of civil engineering applications.
Oh,
And we thought we'd kick off with a field that's maybe a little different than what pops into your head first, environmental engineering.
yeah, that's right. It is distinct because, a lot of civil engineering is about the hard stuff, roads, bridges,
Just
buildings.
structures.
Exactly. But environmental engineering, it really centers on the quality of our natural resources, mostly water and air.
So less about the building itself and more about the health of the environment we're building in.
Precisely. Ensuring
Okay.
those systems are healthy.
And our plan, just so you know, is to kind of walk through the different civil areas. We're starting alphabetically, so environmental's up first.
Right.
We'll eventually loop back to things like construction management, certifications, maybe do those last ones in reverse, just for fun.
Sounds good. And the scope here, it's incredibly broad. You're touching on chemistry, biology, whole ecosystems.
Wow.
Air quality is definitely in there, but a huge, huge focus is on water, how water flows.
Both naturally and engineered.
Yeah, exactly. Natural systems, hydraulics, hydrology, groundwater, all that. And then the systems we build.
And looking at the sources for this, two big engineered systems really jumped out: drinking water treatment and wastewater treatment.
Oh, absolutely central. Yeah, pillars of the field.
They seem key.
And it's interesting, there's quite a bit of overlap. Both involve a lot of biology. Managing how water moves is a very different kind of challenge than, say, structural, figuring out beam loads.
Or transportation, trying to make traffic flow smoothly.
Right. Or geotechnical, looking at soil. Environmental engineering really has to integrate the built stuff with those natural processes.
Okay, so that gives us a good sense of where environmental engineering fits in the picture. Now, let's get to the core of this deep dive. Low impact development, or LID. To really get why LID is, well, necessary, we first need to understand what happens when we do development the usual way.
Right. The traditional approach.
What does building traditional infrastructure actually do to the landscape?
Well, think about, any typical construction site you see.
Okay.
First thing, usually the vegetation gets cleared out, trees, grass, shrubs, gone.
Right.
Then the land itself, the natural shape, it often gets modified. Leveled out, maybe compacted down hard.
Preparing the ground.
Exactly. You prepare the ground, then the new structures go in. So you had a field, maybe a forest.
Yeah.
Now it's cleared, flattened, and covered with buildings, pavement.
And the immediate result, which the sources really hammer home, is that this drastically changes the local hydrology.
Instantly.
Yeah.
Yeah. The way water moves across that specific patch of land and into it changes completely.
It has to, right? If the ground's covered.
Precisely.
Right.
And while, one single project, one parking lot might seem small.
Yeah, just one building.
But the sources use this phrase, development built, one next to another against another. That cumulative effect, that's where it really adds up.
Ah, the scaling issue.
Yeah, you scale that across a whole city, a whole region. The impact on how water naturally flows becomes massive.
And the key change, hydrologically speaking, is pretty obvious when you stop to think. Rain hits the roof, hits the pavement.
Impermeable surfaces.
Right. It doesn't soak into the ground like it used to, not nearly as much.
Correct. And all that water, it still has to go somewhere.
So the traditional engineering fix has always been,
Collect it, get it together, and then divert it, move it away.
which, yeah, you see that everywhere once you start looking for it.
Definitely.
Like the sources point out those retention ponds. You always see them next to the big box stores, right? Walmart, Home Depot.
Target, yeah, near the parking lots.
Those big ponds are just collecting all the runoff from the massive roofs and parking lots.
That's their job. They hold that rush of water, maybe let it seep in slowly, or release it downstream at a more controlled rate.
Okay. And the other big one is storm sewers.
Mm-hmm.
The sources mention the fish paintings you sometimes see on the drains,
Yeah, the don't dump messages.
because that water usually goes straight into a lake or a stream, untreated.
Generally, yes. They're designed to quickly move rainwater away, often directly into natural water bodies.
So basically, the old way is water falls, can't soak in, so we gather it all up really fast and shoot it off somewhere else.
Pretty much. Moving large amounts of water away from where it originally fell and would have naturally gone.
And, okay, that solves the immediate problem of, like, flooding the parking lot.
Right. Where does the water go now?
But it creates other problems down the line. Hidden costs, maybe.
Exactly. Hidden costs and drawbacks are a really good way to think about it.
So what are the big ones the sources flagged?
Well, the first major issue they highlighted is moving all that water somewhere else. It messes with local ecosystems downstream, sure, but critically, it can really impact groundwater recharge.
Ah, the water soaking back down into the earth.
Yes,
Yeah.
replenishing the water table.
And the example they gave for that was, wow, Madison, Wisconsin.
Yeah, that's a striking one.
The cone of depression under the city, that mental image.
It really illustrates the issue, doesn't it? The sources explain it's kind of a double whammy there.
How so?
Well, one reason is expected. The city is pumping groundwater out for its drinking water supply. Standard practice.
Okay.
But the second reason ties right back to this traditional water management. Madison treats its wastewater, which is great.
Good.
But then they discharge that treated water downstream
Yeah.
into a different river system.
Yeah.
It doesn't go back into the ground right under the city where they took it from.
Oh, so you're taking water out from under your feet, using it, cleaning it, and then sending it away.
Effectively, yes. Instead of letting it soak back down and recharge the local aquifer.
And the sources suggest Madison isn't alone in this. Other cities probably have similar situations.
It's very likely a widespread issue, yeah. It really makes you question the long-term sustainability of water supplies built on that model. You might need deeper wells eventually, or complex schemes to move water back for recharge.
It's a fundamental change to the local water balance.
Absolutely, a long-term consequence. And that brings us to the second big drawback mentioned.
Which was the cost.
Yes, the sheer cost involved. And the sources are clear. It's not just building the pipes, the ponds, the treatment plants initially.
Right, not just construction.
It's the maintenance, ongoing, potentially very expensive maintenance. Infrastructure needs upkeep to work like it's supposed to.
Yeah, things break down, pipes clog, pumps fail.
Exactly. And if you don't do that maintenance, the system fails, which causes even more problems, more costs. So that traditional approach locks you into this perpetual high-cost maintenance cycle.
Okay, so let's recap. Traditional development changes the land, disrupts water flow, messes with groundwater, and costs a lot to build and maintain over time.
That's a good summary.
Which naturally leads us back to low-impact development, LID.
Right. This is where LID comes in as a field looking for alternatives. Can we develop differently? Can we build infrastructure that mitigates these negative impacts?
And the name itself is pretty descriptive, isn't it? Low-impact development.
It says what it does on the tin, yeah. Trying to find ways to lessen that environmental footprint, especially around water.
Makes sense.
Now, the sources do acknowledge, LD is a huge field. It's specialized. People do entire graduate courses on this stuff.
So we're just scratching the surface here.
Definitely just the general concepts in this deep dive.
But the basic idea, the core question LID asks, is simple. Is there a better way than what we've always done? Especially now that we see the long-term consequences.
That's exactly it. And, the sources are realistic. They mention LID might not work everywhere or be the perfect fix for every single situation all the time.
Sure, context matters.
But they present it very strongly as a really important approach, something we absolutely need to consider and discuss as a potential alternative in many, many cases. It's about trying to work with natural water processes more, rather than just fighting or diverting them.
So we've kind of traced the path, how traditional building changes the land and water, the problems that creates groundwater issues, high costs, and how LID offers a different philosophy.
Focused on reducing that impact right from the start.
It really does push you to look critically at just standard practices, doesn't it?
It does. And to actively look for ways to build our communities that have a lower environmental cost, basically.
Absolutely. And thinking back to that phrase from the sources, projects built one next to another against another.
Yeah, the cumulative impact.
When you think about that scale across whole cities, it really underlines the massive challenge of managing water in these developed landscapes, doesn't it? Even with ideas like LID, it's a huge, complex system we've created.
Very complex challenge, yeah. And one that really touches on almost every part of urban living.
Well, thanks for joining us for this deep dive into the hidden life of water under our cities and the thinking behind low-impact development. Hopefully, it gives you something new to consider next time you see rain hitting a parking lot.